so everyone can see my screen. Can you see my screen,
Yeah.
Iteps?
Yes, we can see it.
Okay. And this is common. First, there are a couple of questions. Let's start with the floor framing questions. The first one, the direction of a corridor slab, right? So I think there's something, okay, might be there's some confusion. But metal deck, I think you guys understand the one-way slab concept, right? One way versus two-way. Metal deck is something more visually clearly. You could see that metal deck is collocated one direction. So all the load on top of the metal deck, which is concrete and uh, uh, any load on the slab is go follow in one direction, which so metal deck has to support to running perpendicular direction. I think I uploaded some the construction images. So maybe you have to maybe that's something. If you haven't seen that the metal deck yet, I think you to see the construction photos. But I think it's on the floor framing class sessions in Canvas. But your question is, I think this corridor slab because um, it's not like the metal deck is this is just one way concrete slab. When I say it, um, the I think we need this is something more relay with the load directions. The slab is like um, uh, bounded by obviously the corridor the slab geometry. When you look at it, the loads the geometry is more very slender rectangular shape. I think I talked about the one way versus two way is mostly defined by the aspect ratio of the slab geometry. So the dimension one side versus the other side, I think short versus long, if those ratio is more than two, right? That case, you square started turn to rectangular shape. So that case, the load floor, load, gravity load floor is most likely one way. So especially these cases, we are using concrete slab, not metal deck slab, but the load has to be load gonna rotate a floor in short directions. So this case we have to rotate 90 degrees. Let me see. Depends on our local axis. Okay, so you could see this. I rotate that local axis such that loads the one way is defined by or in follow in the short directions. So any loads on top of this slab most likely go flow into short directions. How do you know it? That's maybe the question. Um, this is numerical. If you have, let's say, if you have a paper, right? If you take the paper. Um, let's see, and then maybe not that good. I tried to um maybe is a beam. Probably I have to show it in a different way, but I think that loads are flowing likely flowing in short directions. If we have, okay, I think this is something we could do. If you have as any paper and continuously support all the way like this on along the edge, you see the slab deflection, right? So most likely slab deflect about let's say y direction, about y direction. So you're gonna see the slab deflection like this, like this. So slab is flat, flat. So we have some simply supported. Oops. So slab is gonna deflect like this. Instead of instead of long directions. So maybe I can explain a little bit clearly, but that's something that phenomenon the load has. Load usually find in short direction. So again, this aspect ratio is more than 2. It's very slender, right? Or aspect ratio of slab short direction versus short dimension versus long direction dimension greater than 2, and then you see that load path is more likely one directions. So this area, the corridor slab has to be rotated such that the span direction should be in the short direction. Which how do you know that? It depends on how you draw the slab. But you see that the local axis, the arrows, red, and you see the green line, green color. So when you drew the slab, I think the ETABS has some assumptions. Sometimes when you draw that slab by clicking 4 nodes in counterclockwise or clockwise, I think it depends on how you draw it, that the local axis will be defined. But you could see that all the LED arrows is spanning in plane west-east. So that is a local axis 1. So based on that local axis 1 in plane west-east, that ETABS define that they're one-way span directions. So that is first the response.
I have a quick
answer.
question.
Where is the yes?
Should we pay any attention, since we're doing a composite deck, to which way the ribs are actually going, and which direction they're going? The ribs of the metal deck?
Can you repeat?
Yes, do you know the ribs of the metal deck and how, obviously, there's...
Yes.
Should we have them going perpendicular to the beams? Is that something we should consider? Or is that not a worry?
Perpendicular to beam. Yeah, so here, you see that big arrow? So since you drew the plate...
Oh, so that also rotates the
using
composite?
big course, yeah.
Okay.
So you see that this arrow? Are you asking this arrow that metal deck directions?
That doesn't just change the analysis of the slab, it also changes the direction of the ribs.
One thing, the metal decks, let me turn on the local axis. Okay, here, shell, diamonds, local axis. The metal deck, somehow ETABS doesn't show the local axis. But you could see that when you drew that plate, similar, since you choose the metal deck, right? And I think when you go to deck sections, it's deck sections, and there is some modeling type here, membrane, right? So this is more numerical analogy I keep explain membrane versus shell. This is membrane is has only in plane stiffness. It doesn't have an out of plane bending stiffness, like just normal two-way slab. So this membrane has only in plane stiffness. We usually treat as a diaphragm, but doesn't have doesn't contribute for the lateral bending stiffness. So metal deck, typically we don't count on it. It's just only gravity frame, right? So metal deck, once you use metal deck, is default is membrane, which is correct, and it distribute the load based on the metal deck directions. Similarly, the slab could have, but slab could have two properties. So when you go to this 6 inch slab here, right? Generally, there is a modeling type has membrane, shell, thin versus thick layers. Typically, you're gonna use either membrane or shell. So membrane here, when you use it, this one has also only in plane stiffness, but slab, I think ETABS create another option that engineer can define that load distributions, whether in one way versus two way. If you turn off this is some most loads will distribute some it could be one way, two way. It depends on the slab aspect ratio. So this is something very relatively advanced. Maybe I could find out some example how you could visually see it by using some small model. But just slab for these cases, we not count on the bending stiffness for lateral system. So we're gonna use just six slab and membrane features, and also use a 1A load distribution, so we could design the slab as needed. So, but I think metal deck, you could see that all directions are in perpendicular to filler beams, right? This is all filler beams. I'm referring to filler beams, and the girder is typically parallel, right? So this is a kind of basic that beam versus girder and the slab. Obviously, it depends on the load path, the sequence of the load. So any other questions on this? I think this has moved down. I'm not sure that how much you have some experience on the structural model, but I know that if this is pretty new, I think I believe you guys have some maybe a relatively hard to understand. So as you get more experience, I think this what we are discussing is pretty common